Buddy. Today I'm gonna show you why all objects of different masses will fall at the same time. So for example, let's take a let me just change the ink. Okay, so imagine this to be a 5 kg ball and imagine this to be a 10 kg ball of different materials or same material, doesn't matter, just the weight mass matters. So if you drop them from the same height, they will touch the ground exactly at the same time. This can be explained by using universal law of gravitation that states that the gravitational force is directly proportional to the masses and inversely proportional to the radius. So from this we as we know the universal law of gravitation is given by the equation Fg. This is the force of gravitation, that is G m by r square. G is a gravitational constant, which is 6.67 into 10 to the power negative 11. So let's keep that aside for a while. Mass is the object of the masses. M is the capital M is the mass of the first object, and the small m is the mass of the second object. And this equation will give us the force between these two objects, which are at a distance of r squared actually. Okay, so now we understood the gravitation, the universal law of gravitation. Now let's take a look at Newton's second law of motion. Newton's second law of motion states force is directly proportional to the mass and acceleration, F equals ma. So this Fg, we can replace it here and use this F, because gravitational force is given by Fg and F is equal to ma, so it's from the same thing. So let's take now, oh sorry, let me just erase this bit over here. Where's the eraser? The eraser is over here. Okay, so let's erase this part and let's take a pen. Okay, now let's state the Newton's second law of motion. Okay, F equals ma. But now we would like to calculate the gravitational force, which is given by Fg. And as we studied, Fg is equal to G m by r square. In this case, the mass of the object, this is the mass of the Earth, which is 6 into 10 to the power 24. Okay, and the radius is something, I guess, is 6.4 into 10 to the power 14. Let me just check it. The radius of the Earth, it's actually the distance between the center, because Earth acts as the Earth acts like all of its mass is concentrated at the center. So the distance, this is the radius, and the object may be here. That's what I mean. Let me just set the radius. So I think, yeah, it's 6.4 into 10 to the power 14. If I'm sure, I think it's 14 though. I don't think it's 14. Let me just check it again. I think it's 6. Let me just check it in exponents. Exponential form, yeah, in exponential form. What is the graph in exponential form? In exponential form, okay. Just hold on a second. It's 6.3 into 10 to the into 4 into 10 to the power 6 actually. Yeah, that's what it is. And m is the mass of the object. Suppose the 5 kg ball or the 6 or the 10 kg ball. It doesn't matter. Now you put ma, universal gravitation. From this we can see that mass cancels out. That means in this equation we can simply say that the mass of the object has disappeared. So if it wouldn't matter if it was 5 kg or 5 kg, if it was 10 or 10 kg, they would have just simply gotten cancelled out. So the acceleration of a free falling object. This is in the case that no external force acts on the body. That is, there is no sideway push. It's only influenced by the force of gravitation. So all objects, irrespective of their masses, is given by Gm by r square on Earth. Now let me just show you the numerical form of it. Okay, let's just take Gmm by. It's a very simple form. I just need a calculator. Let me just check on the calculator. Or it's just fine. We can calculate on the computer. So let's take Gm by r square. Gmm by r square. Okay, universal law of gravitation. 6.67. 6 into 10 to the power negative 11 into m is the mass of the Earth. I'm sorry, I just wrote did too big, so it won't fit in the whole screen. Okay, and m is the mass of the object. Let's just take it for the first 5 kg ball. We'll take it for the 10 kg ball in the later on. Okay, 6 and the radius 6.4 into 10 to the power 6 into 6.4 into 10 to the power 6. Okay, so pretty simple here. Let's just calculate the rest of the part. Let me just open the calculator. Just hold on for a second. Yes. Okay, so let's just multiply 6.67 into 6. Okay, we got, and let's multiply the 5 also with it, so we can finish the calculations. So it comes to be this into this into this and this. It comes to be 200.1. okay, and bases are same, powers are added, 10 24 plus negative 11, and let's just check below. So let's just go 6.4 to the power 2. It's one of the same. Oh yeah, so it comes to be something like 40.96. okay, and 10 to the power 6, this is the same, powers are added, simple math. And now let's just divide 2001 200.1 divided by 40.96, yeah. So the value comes out with something like 4.8. Am I doing it right? I don't think I'm doing it right, so I think I caused some problem somewhere. Let me just check. Am I doing everything right? Yeah, everything should be right. Yeah, it's gonna find. Yeah, so it comes out to be 4.88. Let's just take small values so we can easily calculate it later on. And now the value we'll get over here is 24 minus 11. That's, I think, like a 13. Let's just check to be sure. My math is very bad. I'm very bad. Yeah, it's 13 into 10 to the power 13. So it's going to be subtracted over here, and then since we divided these two, we will have a value. This is the only value left downstairs. I think I'm doing right. Yeah, 4.88 into 10 to the power 13. Bases are same, powers are divided. Same math. It comes to be 1. That means it's 10. 4.88 into 10. So 4.88 into 10. It's actually 48. It's into, oh shit. Yeah. Just hold on a second. 48. Oh sorry. 4.88 into 10. So it's going to be 48.8. okay. 48.8 newtons. Yeah, that's the 48.8 newton. So this says that if a body of 5 kg is dropped from a certain height, it will have the gravitational force acting on it will be 48.8 newtons. That's simple, isn't it? And let's just take up this zoom so we won't make much of the paper. Now let's calculate the gravitational force for the 10 kg object. Okay, so let's just write down what we got the value. We got 48.8 newtons for the 5 kilo object. Okay, now let's just check gm by r square, sorry. And now let's check g 6.67 into 10 to the power negative 11 into 6 into 10 to the power 24 into 10 kilo into the 10 kilo object. Okay, so let's divide it by 6.4 into 10 to the power 6 into 6.4 into 10 to the power 6. Simple. Okay, let's just multiply it again. I'm very bad at mathematics, so I'm going to simply use a calculator. Into 6 into 10, the mass of the object. Okay, so that's the answer coming 400.2. okay, into 10 to the power we know the mathematics, just keep that part. 6.4 into 6.4 is 40.96, I guess. 6.4, oh shit, into 6.4 is 40.96, yeah, and into 10 to the power 12. So just divide 400.2 divided by 40.96. It gives us a value of, okay, it gives us a value of 9.77 into 10 to the power 1. That's 90. Let's just approximate 98. It doesn't matter. So it's gonna be 98 newtons just for simplicity. So now for the 5 kilo object, force is 48.8 newtons, and for the 10 kilo object, the force is, let's just take this to be 50 newtons, so that for simple, so that it's easy to calculate it, and 98 newtons for the 10 object. Now let's bring in Newton's second law of motion. Simple. So we took 50 newtons, F equals ma. The force for the 5 kilo object is 50, the mass was 5, the acceleration is gonna be 10 meter per second squared. It's actually approximate. Since we approximated the value, we got an approximate value of gravitational force, 8 meter per second. If we had done 48.8, if we had taken 48.8 divided by 5, divided by 5, we would have got 9.76, which is actually 9.8 newton, 9.8 meter per second square. Okay, and same as in the case, it's pretty simple. 98 divided by 10 for the 10 kilo object divided by 10 is going to be 9.8 newtons. So you can see 9.8, 9.8. It doesn't matter, the mass of the object was never a variable in the whole equation. So irrespective of the masses, objects will fall at the same time. I hope you understood what I mean to say, and please, if you think the video was good, so please like the video and share it and subscribe it. Thank you.